starting chapter 4 today, graphing quadratic functions. First thing we're looking at is the parts of a quadratic function. That first little term there, I want you to be able to identify all these, is called the quadratic term. Okay, so when you see an x squared, if I talk about this right here is the quadratic term. Any ideas what the middle one's called? If we didn't have the first term, if we didn't have that squared term, then what kind of equation would that be? Equation of a what? A linear term. An equation of a line. And then when you have just the number by itself, that's called the constant term. I'm sure you heard it because that's what I call it. So you should have heard me say that before. Okay. So just the parts of a quadratic function there. Of course, when we see f of x and y are interchangeable. So if you see f of x equals, or if you see y equals, and you see an equation that looks like that, then you know that it is a quadratic function. Okay, so it doesn't have to have the f of x there. Okay, so here are some things that we're going to find of our quadratic function. The graph is called a parabola. That's that word right there. That's what the graph of a quadratic is called. And there are some parts of it that we're going to be able to identify. Okay? If we look back up here, the c, the constant term, that's the y-intercept. Okay? Not too far of a stretch there. Does the same thing in y. That what we call the b in the line of an equation was where the y-intercept was. And then we have this nifty little equation here that helps us find the axis of symmetry. What is the axis of symmetry? Well, if you were to have, this is what a parabola looks like, something like that. The axis of symmetry, grab your notes right there on the edge of my desk. The axis of symmetry is this line that runs down the middle, straight smack dab down the middle of that graph. Okay? Going through the vertex. Okay? And there's this nifty, so you're not having to guess what it is. You can take the parts of your quadratic function, the b and the a, put it in this equation, and it gives you the axis of symmetry. Not hard to find at all. As long as you know what your a, b, and your c are, you can find all this stuff. And then the x-coordinate of the vertex, so this right here, when we talk about the x-coordinate of my vertex, it's what you just found to be, it will lie on your axis of symmetry. Okay? Okay, so let's look at a problem. So that'll make all that make sense. So you have this in your notes, so you don't want this to go far. Okay, the first thing we want to find, here's our equation, we're going to graph it. And this information in this little box up here, all that will help us find our graph. Okay, so we're first going to find the y-intercept, so that's whatever c is. The equation, okay, so here, I like to underline the equation of the axis of symmetry and the x-coordinate of the vertex. Okay, so basically everything in this box we're going to find. That's part A. Okay, okay. So A. So what is my y-intercept?
6.
It's what?
6.
6. Yeah. So I already know where it's going to cross the y-axis. My graph. Okay. Okay, got that. Axis of symmetry. Okay. And if you want, sometimes it might be helpful to just go ahead and A is -5. B is -10. C is 6. See where I got all those numbers? Okay. Go back up to the top, and that's my A, B, and C represented from my quadratic function. Okay. Okay. So now I'm finding the axis of symmetry, and we'll just, anytime we label it, I'm just going to put AS for axis of symmetry. And that way, if you're looking at it, and what's the equation for that? X equals -b over 2a. Now I'm going to substitute the B and the A. Okay, so I'm just going to look up here. What is that? Can't see it in your head? Can't see that? Then simplify. Simplify the top, simplify the bottom. And what do we get? 1. -1. Okay, so that right there is my axis of symmetry. Okay, so let's look at what we have so far. Okay, so I have my y-intercept. It's right here. The axis of symmetry is always going to run vertical. Okay. Okay, so where does it say it's at -1? It's right here. So fine, this is our x-axis, right? So this is, what this is I'm graphing is the equation x equal -1. So that's where it crosses my x-axis. That's where it hits it. It's right here. I'm not going to draw a line. I'm just going to draw a little dash line. Because it's not actually part of the graph itself. It just helps us identify where things are.
Will it always be dotted?
Yes. It will always be a dash line. Okay? Trust me, I am showing you the very easiest way to graph these on your paper. Okay? Someone's done all the hard work for you. Okay? Someone's already discovered that, hey, I can just look at C and that's the y-intercept. Hey, I can put B and A in this axis of symmetry formula and I can find out what the axis of symmetry is. There's no guessing on this. Okay? Okay, and the x-coordinate of the vertex. Well, let's do this. What's the x-coordinate of my vertex? X-coordinate of the vertex is, does this thing look familiar? It's -1.
Wait, how do you do that?
The x-coordinate of the vertex is -b/2a, which we just found. We just found it.
So does it always be the same?
It will always be the same because what it is, that's the vertex will always lie on the axis of symmetry. So whatever the axis of symmetry is, that's going to be your x for the vertex. Okay? So kind of like when we were graphing the absolute functions, we found out where that vertex was. Okay, so now I'm going to make a table of values. Okay? And in that table of values, I'm going to put my vertex in the middle. So then I'll pick a number on either side of -1. They don't have to be exactly the same distance. They don't have to be, but I always like to pick numbers that are. Give me a number to the left of -1. To the left. -2. Now to the right. 0. Okay. Okay. Now I'm just going to plug those numbers into my original function. Okay. That's why it's f of x, but I'm just going to do that part right there. So I'm going to go through and I'm going to substitute x with -2. And you can type that into your calculator just like that. Okay. I'm going to, I should put a y in front of there. I apologize. Because it is what y equals. I'm not really changing anything except for putting a y equal in front of it. Okay, then I'll figure out what that is. And then I'll go here and put -1 in. Well, what is that? We already know what this is. And that's going to be, I already know what that point is. Because it's at my, crosses the y-axis. That just happened to be the point we picked. Because if your x 0, they're gone, and it's whatever is left right there. You want to get the first one? Yep. 6. Oh, you got 6. You didn't get 6. You did something wrong. Remember when you square those numbers, they're positive. This is a negative. This becomes 4. It becomes negative 20. Okay. Plus 12. Plus 6. I'm sorry. Plus 20. Should have been 6, shouldn't it? Because look, if you pick points on either side, they should be the same. The y should be the same. If you pick the same distance. What is it when it's negative 1? When x is negative 1, what's y? Try it again.
Wait, why was 0 and 6?
0, that becomes 0, that becomes 0 if I put a 0 in there, and all I have left is plus 6. And I got the negative 1 yet?
It's 11.
11, yes. And if you didn't get 11, you just have to try it again. And that's just simplifying. That's pre-algebra. Okay. Okay, so if I plot these points, so 11's right there. Okay. Kind of looks like a triangle. It's not. I already showed you what the graph looked like. It looks like a U. It's going to look like this. And here. Because you do not make it look like a V. Really put a curve in there. And it's hard when they're skinny. Drawn. But as long as okay. And any questions? Wasn't bad, was it? Oh wait, we're not done. Use this information to graph. Okay, we did that. That is our C. This is our C.
That one will always make a table.
If B said make a table of values, so yes. Yeah. Okay. Any other questions? Trust me. Everything hard here has already been figured for you. Keep that in mind when you're doing this if you get a little frustrated. Okay. Somebody's already come up with, how to make this easier to find. Okay. What am I make sure right here? Okay. Draw you 2 little axes. Is that how you could say that if I was talking plural? I do believe so. Let's write the quadratic again. Put it right here. So make sure you got this. It doesn't have to be perfect. Just going to give you a general idea. Okay. I had you write the function again. Why is it important that A does not equal 0? Do I? Say so. What happens if A is 0? Yeah, it's a line. If A is 0, you no longer have a quadratic equation. You now have a line. So A has to be a number. Means it can be anything but 0. Okay, so just in general, write maximum value across the top one. And go ahead and write minimum on the second one. Didn't leave myself enough room, did I? Minimum. Try to spell that right. Maximum value and minimum value. Okay? Now, where it is located on this graph is not important. What's important here is that this graph opens down. Okay? So it opens down. And A is negative. I already saw somebody flipping over to look at the problem that we just... So if we look at this one that we just graphed, this graph has a maximum point right here. My A was negative. So if it's negative, if the x squared term is negative, then you know it's going to open down.
So it doesn't necessarily have to be in the negative part of the graph.
No, okay. No. It's just the way that it opens. So if it's positive, your graph will look something like this, and it will have a minimum point. Okay, we'll open up. So it opens up. And A is positive. Okay, don't make it harder than what it is. That's just to help you kind of, when you see the graph, before you graph it, you kind of know what direction you're going.
Will it ever like open up and A be everything?
No. Nope. Okay. So this one, okay, let's just look at it. First of all, my function here, my quadratic function here, does this have a max or min value? Here's my A. So if A is positive, what was it? It has a minimum. So what I mean by the minimum value, it's what the vertex is. The minimum value or the max value is the vertex. Okay? Okay, so there's nothing extra that you have to find. Okay, so we just decided that it has a minimum. Okay, so somewhere on your paper you would put minimum. Okay. Okay. State the max or min value of this function. What did I just tell you?
It's going to be your vertex.
Right, it'll be your vertex. So we're actually looking for the minimum, right? Okay. So I'm going to identify my A is 4, my B is negative 24, and my C is 11. Okay, so it looks like we need to find x equals negative b over 2a. That locates our axis of symmetry, which also helps us find our vertex. Okay, so go ahead and plug those values in.
Wait, wouldn't it be A?
Yes, oh, I added. Yeah. Okay. So what's the 3? It's the axis of symmetry. Okay. So this graph is kind of weird. So it's not weird. So to find the value, how do I find the y if I already know the x?
Isn't it the same table as whatever?
Okay, you want to go ahead and just make a table? Let's go ahead and make a table.
Wait, why wouldn't it just be 11? Because C is 11 and that's the y-intercept.
That's the y-intercept.
It's not what we're looking for.
No, we're looking for the vertex. Yeah, could they be the same? Yes. But we don't know until we plug. What do we want to do? We want to do 2, 3, and 4? Because we already know this is our vertex. Okay, so we might as well go ahead and find. But we just got to make sure that we still find that we answer B. Okay? Okay, so we put 2 in. just put all kinds of, oh, okay. I did that. That should be right there. Trying to figure out why I might be the same. Should be getting. Maybe I did the other one wrong. Because I got maybe I need to finish it. Okay. Okay. I did get 21 that time. That's fine. See, I noticed. I mean, when I did this one, I know it should be whatever this one was. So I didn't get negative 29. So I'm like, oh, something's wrong. Because I did this one, like, again. I got negative, well, maybe this one's wrong. So know that those two are the same. Okay? Okay. So we need, how far down does our vertex go? To negative 25. Now, get that one like that.
So the middle one will always be the vertex? Or it will always, yeah, it'll always be.
Well, I made it. I mean, I knew that the X was 3.
Yeah.
So I just, visually, it makes sense to me to put it in the middle. You don't have to, but it just makes sense to me.
And how do we find the Y? Oh, you just grab all of them?
I just plugged in, yeah. Okay, so let's see, we got 1, 2, 3, 4, there's my X's. So 2 is like negative 21, so I'm just kind of guessing. Okay, you don't have to be exact. And where does it cross? Crosses at like 11, so that might be about right here. Okay. If it makes you the letter to put a negative 25. I mean, you know, just kind of mark it for me. I don't expect you to count out to 25, negative 25. If you'll just mark it, I know, and you're kind of guessing where you plot it. Okay? Okay, so when you got big numbers like that, don't worry about, you know, or sometimes you can do, instead of increments of 1, you could do increments of 2 or 5. But I didn't do that because my X's were increments of 1, so I thought, well, I'll just kind of just mark it on it.
So the vertex is 3, negative 25?
Yes. Yes, thank you. So that would answer this right here. So that right there, that is the minimum value for this function.
Because it opens up.
That is the lowest point, the minimum value on this graph. Okay? Minimum, the lowest, smallest, the lower, smallest, the lowest. Okay, we still got to take care of C. Okay, domain and range. Oh, everybody loves domain and range. Domain. We want to make sure I get my notation right. Oh, well, this one. Oops. This is going to be all real numbers. We talked about this before. Okay, when we have a parabola, I think we had it on the, when we were graphing absolutes, the domain or your x can be anything. Okay? X can be anything. Think about it. I can put any number in there I want for x. Okay? Well, but my range, now what is the domain? Is domain x or y? X. X. Okay, so my range, I am going to have some kind of restriction. How far? lets that go down. Negative 25. So is my y greater than negative 5, or is it less than negative 5? It's greater. So your range is y is greater than or equal to negative 25.
Will always be equal to.
Yes. Yes, because it's your vertex. Okay. So, do you see any similarities between your range and what your vertex is?
So that's not the y-intercept, that's the vertex.
Right. And we could have put our y-intercept on there. It was what, 11? That's why I plotted that there. So this right here will be determined your y value. So go back and look at your y value of your vertex, and you just got to decide is it greater than or less than and equal to. It is always equal to.